Since its inception, man has been eager to know the secrets hidden in the heavens, and his efforts have met with a great deal of success till the present day. Today, one of the same achievements, I have come to you with a documentary about Mars. Humans use different types of orbiters, rovers, spacecrafts, robotic machines, etc. on the planets. But how this work is being done, we will see in this documentary. I have divided this documentary into small videos, and in these videos, we are looking at different things. We will first see what kind of planet Mars is, why it is different from Earth, and why the technology we have built on Earth cannot work on Mars. In addition, we will see how the means of communication are used when the rovers and shuttles are sent into space, and how we can communicate with them. What are the challenges we face in space? Then we'll look at deep space networks in detail about what challenges Mars faces, along with a history of which rovers and which orbiters we've sent to Mars. Most of the rovers and orbiters made by NASA, so all data that we have given is from NASA and also from the European Space Agency, but we have received very little data from them. Won't be discussed in too much detail. So their rovers and their orbiters won't be discussed in too much detail. So how is it working, and then when will humans go to Mars, and how will they go? What kind of technology will be used? How will humans land on Mars? How will they settle on Mars, because there is no oxygen on Mars? But will we be able to settle the colony in the same way as we settle it on the ground? Not at all. It will make a lot of difference. But most of the focus will be on how we make changes in engineering and design so that we can go to Mars. We will create the videos regularly, and we are going to start with Mars. During the time of ancient Egyptians, when they looked at the sky at night, they saw many stars. They saw star constellations, but at the same time, they saw some stars that were very fast. They used to move in the sky compared to the stars that were stationary. The Egyptians called them wandering stars, but now we know that these were not stars, but they were planets, the way the sun shines on the moon. And it looks like a star to us, but because it's so close to us, we know it's not a star. It's a moon, in the same way that these planets in our solar system. When they shined in the light of the sun, we thought they were stars, but their movement was very fast. It was called red star because it gave a brownish shade to the sight, but is the land of Mars really brown? And if its rocks are green, then why are they? I will take you to my land. If you explore the different parts of the earth, go to America, see the Grand Canyon. Go to the place and look for the lunar rocks on the earth. You can find many lunar rocks. When scientists look at these rocks, they do a chemical analysis of the soil of these rocks, and then we find out that these rocks are very high in iron, and because of that, when the iron reacts with oxygen, it will form in these rocks. But it is not all one color. There are different shades of brown, but also shades of green will be visible to you. But when we look from a distance, Mars appears to us red, or it looks brown in color. Why do we want to go to Mars? I will give you the answer from the history of man. Science tells us that man was born in Africa from 300,000 to 1,000 years ago, and then slowly, Africa was settled, but the whole of Africa was not yet settled. That man came out of Africa. Curiosity took him out to explore. On the way to see the land, seas rose and rivers rose. Then he resorted to technology. He built a ship. And when he crossed the rivers through technology, crossed the seas, in many places he had to make warm clothes because of the cold. he started slowly populating the Earth. He started getting the resources of the Earth. When the benefits started to come, the man learned from his movement to go to a new place due to his curiosity that there were many resources and opportunities to improve his life overall. When we're all spread out on Earth, we're looking into space. We're trying to get to Mars so we can take the next step, and human curiosity is pushing it. Let me tell you why we chose Mars. If you look at the planets in the upper solar systems, the last 4 planets are Jupiter, Neptune, Saturn, and Uranus. And these are planets made of gas. Humans cannot live on these planets. At the time, we do not have such technology to visit them. They are being explored by different orbiters, but humans cannot settle on them. Let's go to the other side of the world, closer to the sun. Then we will go to Mercury. But Mercury is much closer to the sun, so it is very hot during the day and very cold at night. If we talk about Mercury, its temperature is from 170 centigrade, i.e., from negative 170 centigrade to 448 centigrade. We don't even have air on Mercury. It doesn't have an atmosphere, and this is also a big problem for humans. Now, we can't even go to Mercury, so let's talk about Venus. It is the hottest planet, even though it is farther from the sun than Mercury, but it has a temperature of 465 degrees Celsius. It has a huge layer of atmosphere, which is 93% heavier than the Earth, and that is why sulfuric acid rains on it. So how can you live where sulfuric acid is raining? Now we have only Mars left, so now we move towards Mars. If we want to settle on Mars, then we should know about it. The gravity on Mars is 38% less, which means your weight 38% less, so you can play basketball and do long jumps there. Mars is the smallest planet in our solar system after Mercury, and its land mass is much less than our Earth's land mass, so we won't find much land mass when we go to Mars. Here we will face a lot of difficulties because when we have to take the rovers or any spacecraft to Mars, we will have to face a lot of technical problems there because of its atmosphere. Let me also tell you that there are 2 moons of Mars which you can see here. These 2 moons are not like the moon of the Earth. There are 2 rocks from the asteroid bed passing by Earth's Mars which are rotating around Mars. Mars also has a tilt like the Earth. You know that our Earth does not revolve around the sun in a straight line, but it tilts at an angle of 23 degrees. On Mars, this tilt is 25 degrees, which means all the seasons that occur on Earth are due to this tilt. So on Mars, because the weather is on the same side, there will be the same weather and in the same pattern as it is on Earth. We will discuss the weather on Mars further, but at the same time, I told you that the gravity on Mars is 38%. The gravity is much less than on Earth, so your weight will be less there, and because of the gravity there, difficulties will also be faced. The diameter of Earth is half the diameter of Mars. It is 53% diameter compared to Earth. This means that Mars is half the size of Earth. So the size is half, but the mass is much less. If you look at the atmosphere of Mars, the most gas you will find here is carbon dioxide. Carbon dioxide is 95 to 96%. Nitrogen is 3%, while oxygen levels are very low. What's surprising is that oxygen levels on Mars change throughout the year. Scientists are still doing a lot of research and trying to find out the reason. I've already told you that the seasons of Mars will be exactly like those of Earth, but because the orbit of Mars is large around the Sun, the sunlight is lost on Mars and the temperature is also lower. The orbit that completes one cycle around the Sun is 687 days, and its seasons are also longer than Earth's. So, summers also come for a long time, and winters also come for a long time. If you talk about the day temperature on Mars, it varies from 0 centigrade to 24 centigrade in winter, but the night temperature ranges from minus 110 degrees to minus 140 degrees centigrade during the coldest nights. Because we have to take the technology to Mars, the solar panels on top of the rovers, which are receiving sunlight. We have technical problems there because of long winter. We also have to look at how we can store energy in rovers to survive in long winters. Here, let me also tell you that after every 26 months, Mars and Earth come very close to each other in their respective orbits. So, if we want to get a rocket from Earth to Mars, we wait for the moment when Mars and Earth are completely aligned and then fire the rocket to where it will be for 7 to 8 months. Then there will be Mars. So the rocket is fired into the future. Because we need 7 to 8 months to reach Mars, we are going to discuss this a lot further. Look at the hills of Mars. Because Mars is smaller than the Earth, we can guess that the hills of Mars will also be smaller than the Earth. But if we look at Mount Everest, which is the highest mountain on our Earth, the peak is 808 km from the sea. And if you look at the highest mountain on Mars, which is called Olympus Mons, its height is 27 km from the sea and its width is 550 km, so it is 3 times bigger than the Mount Everest. Now the question is arising, what is the reason for this? This is the absence of tectonic plates on Mars. If you look at our Earth's crust, which is the topmost surface known as the lithosphere, moves above the Earth, but this movement is so slow that we cannot perceive it. Now, when the lava comes from below, a volcano erupts, and the volcano erupts. Small hills are formed because the lava comes out from one place, and after some time the surface moves from there, and then there is a small hill. A hill was formed and then it grew. But on Mars, the surface doesn't move, and when the surface doesn't move, the lava just piles up where it comes out and it forms a huge hill. So the Olympus Mons that I mentioned to you is that. It is a very big hill. If we compare Earth with Mars, the weather conditions there are harsh. There are a lot of dust storms on Mars, but because the atmosphere on Mars is very thin when dust storms occur, the dust that spreads on Mars takes a long time to settle down. And because of this, these dust streams slowly settle down. Mars is engulfed by the way you are seeing the dust streams of 2001. This is not one dust storm, it was multiple dust storms. Now, if we were to send the rover there and these kinds of dust storms came, then we would have a lot of problems because our cameras would not work again. On Mars, the clouds are frozen, the temperature is very low, and if you send a rover there or you land a spacecraft there, then there can be a lot of problems. Cyclones on Mars are also there, the same way there are dust devils on Mars, which are little tunnels that go around and go up. Its height can be up to 4 kilometers. What difference does the height of 4 kilometers make to us? If you think about it, the head of the atmosphere of Mars is 11 tectonic. At an altitude of 11 km, the Martian atmosphere starts because it is 1% of the Earth's atmosphere, and 4 km is a huge difference. So, if we want to send anything to Mars, its weight will increase in the same way the size of our rocket will increase. If there is, then a big rocket is needed, and if a human being is to be sent, then an even bigger rocket is needed. Also, the timing has been mentioned earlier. Because we will launch the rocket at that time while Earth and Mars will be face to face and close to each other. To be continued.